Good afternoon. We're waiting for the resource person to join. Engineer Biju Paul. Sir, Biju Paul.
Yeah, good afternoon.
Yeah, good afternoon. Can you please
Uh,
confirm his whether he's facing
yeah,
the
he is facing some technical issue. He told that within 5 minutes he will join and start the section, sir.
okay, fine.
Hello.
Yeah, Lakshmi Narayan. Okay.
Good afternoon, sir. Sorry for the delay.
Yeah, it's okay. Let me let me read out your profile and you can start. Okay. Good afternoon,
Yes.
everyone. This is the last session of this FDP. I welcome Engineer Lakshmi Narayanan of Andritsu India Private Limited, lead engineer in the RF support team. He has over 15 years of experience in the RF field, and he'll be discussing about the basics of VNA applications and the Andritsu portfolio. Okay, over to you, Lakshmi Narayan.
So good afternoon, sir, and good afternoon, everyone. And today we will discuss on Andritsu. So let me read my PPT, open my PPT. Just a minute. Are you able to see my screen?
Yes, sir. Go ahead.
Yeah, it's
Yes.
visible. Go ahead.
Okay. Now?
Absolutely
Yes, sir.
okay. Please.
Yeah. Okay.
Okay. So today we will discuss on VNA network analyzers. Today we'll be looking for introduction to Andritsu, fundamental of network analyzer, basics of transmission line, and VNA for passive and active devices, and VNA architecture, and characterizing of antenna using a VNA, and some of the basic measurements you will come to know, and we will go through our Andritsu portfolio. So Andritsu is in Atsugi Shi Company, Japan. So Andritsu was established in March 17, 1931. We are more than 4,000 employees worldwide. And in 1990, Andritsu acquired the Veletron company in the USA, a measuring instrument manufacturer. In 1997, Andritsu established operating companies in the US, UK, and Hong Kong, and integrated its head office and features in Atsugi. They are the first to introduce a receiver for radio broadcast and first to introduce a TV broadcast transmitters to Suzuki University and automatic public telephone, and they are the first to AC bias magnetic recorder, and they are in the CA WCDM profiles and in a communication profiles also, where they will be supporting for the 3GPP and 5G network manufacturing for production units, and they are giving supports in the Qualcomm manufacturing like Qualcomm, Samsung. So we are supporting for them in the manufacturing units for their UV tests. So now we will come to the transmission line. In the slides, we will be introduced to the concept and some basic theory of a transmitter lines. The concept of transmission lines is basic to the understanding of RF and microwave technologies. RF transmission lines can be made in a variety of transmission medias like twisted cables, coaxial, coplanar, strip line, and microstrip. And RF circuit designs, as we know, RF circuit designs are on printed circuit boards, use often the microstrip and coplanar lines for their designing. So when you come for the characteristic impedance, the fundamental parameter of a transmission line is its characteristics impedance Z0. The characteristic impedance Z0 describes the relationship between the voltage and current traveling waves. It is a function of the various dimensions of the transmission line and the dielectric constant epsilon R of the non-conducting material in the transmission line. For a low power situations like cable TV For example, the coaxial transmission line are optimized for a low loss, which works in to about a 75 ohms, as we know. And for RF and microwave communications and radar applications where high power is often encountered, the coaxial transmission lines are designed to have a characteristic impedance of 50 ohms. So why we need a 50 ohms? So this will be the question. Some of the time it will be arriving. Why we will need a 50 ohms? The range of the impedance of for a reasonable mechanical ratios, for example, if outer dia D by D varies from 1.5 to 10, the impedance for an air dielectric varies from 24.3 ohms to 138 ohms. So any mechanical easily made coaxial line is going to have a characteristic impedance around 25 to 100 ohms. For a, suppose if you take for a Y, we need a 50 ohms, the ratio will be the ratio of the D by D will be somewhere around 2.3. Why? Once again, the same question remains, why 50 ohms? The lowest attenuation occurs when the inner to outer dia ratio is 3.6, which corresponds to the impedance of 77.6 ohms. On the other hand, because of the electric field strength is highest near the surface of the inner conductor, this field strength could cause a breakdown if too high. By calculating the voltage breakdown in air and the transmitted power in a reflectionless line gives a diameter ratio of 1.65, corresponding to 30 ohms. A compromise between the maximum power handling occurring at 30 ohms and minimum loss of 77.5 ohms, the coaxial transmission lines are designed to have a characteristic impedance of 50 ohms to compensate between the lowest attenuation to optimum power capacity. So the maximum power transmitter, whenever there is a signal, as we learned in the theory in the colleges, whenever the source impedance matches to the load impedance, the maximum power can be transferred. So for a maximum power transfer, it should be the load resistance should be matched to the source resistance to match to the load impedance is equal to Z0. Next, let's terminate our line in a load, and we will see what happens when there is a load is connected to the termination. So no reflection signal will occur. All the incident power is absorbed by the load, and where the signal will be incidented, same as if a transmission line very infinitely long, it remains the same for the long transmission lines also. The RF voltage envelope you can see is a constant line. No standing wave is there in the signal. When you come for the, if there is, this is the same for the same distance. And next, let's terminate our line in a short circuit. Since it is a purely reactive, elements cannot dissipate any power. So there is a nowhere else the power go. A reflected wave is launched back down to the line towards the source. It will be 180 degree out of phase of the signals. So our reflected and incident voltage waves will be identical in magnitude and both are in opposite direction. In the next, we will connect a open in the transmission line at the end of the transmission line. Here the reflected and incident current waves will be identical in magnitude but traveling in the opposite directions, and it will be in the in phase the direction. Let's finally terminate our line with a 25 ohms load. So some of our incident energy will be observed in the load and some will be reflected back towards the source. We will find that our reflected voltage wave will be having an amplitude of 1/3 that of an incident wave, and that the two waves will be 180 degree out of phase at the load. So next we will go to the termination network analyzer part. So as we know, the network analyzer, there will be two types of network analyzers. When you are talking about the internet or IT people, they will talk about the server network analysis. And when you come for RF engineers, they will talk about the RF component characterization. So this, what we will be talking, it will be related to the RF characterization of the RF components. So what is a network analyzer? A network analyzer is an instrument that measures the network parameters of a electrical networks. So what we will be measuring as a S parameters, depending on the reflection and the transmission of the signals. Why we will be using the S parameters? Because the S parameters are used to measure at a high frequencies. So that is the reason why we will be not considering a Y or a Z parameters. We will be considering as a S parameters in the network analyzer. RF and micro measurements characterizing a high frequency for active and passive devices. Magnitude is alone for some of the cases where you will be measuring the only the gain or the loss of the components or attenuators. In that case, the magnitude is only sufficient. And why we need a phase? When you are measuring the complete characterization of a linear networks. Like if you want to measure the linear networks, means you can measure the amplifiers like group delay, phase related measurements. In that case, you need the phase also. And for accurate simulation, circuit simulation of the device, and some of the designing efficient matching networks, when you want to match the networks from 50 ohms impedance, like if you need a Smith chart kind of thing, you can be using the phase and a magnitude value both. So for a time domain characterization, where you will be measuring the time domain axis in the frequency domain network analyzer. So why users need a VNS? VNS are used to characterize RF components, as I told, used in a multiple environments, like characterize devices for a research and development, and they will be using for a manufacturing to test their conformancy test, whether it is pass or fail within the range. Used with the different packages and configuration devices, depending on their coaxial connectors, and some of them need a 2-port and a multi-port for a multiple port for RF conversions, where we need a LO, RF and LO, RF and other IF signals. And for a single-ended and differential measurement circuits, we need a different configuration, and depending on the waveguide connectors, we can provide a waveguide connectors. And for a contact connectorless fixtures like microstrip and a strip line, we can use a fixtures to connect directly to the board, and we can analyze in the network analyzer. So these are some of the material measurements for optical to electrical electronic converters. We need the network analyzers, and there is a different configuration for that. So these are some of the applications where you will be using the network analyzers. And most of the users need network analyzer to measure the S parameters, transmission and reflection characteristics, and for the gain measurement in the amplifiers, where we will be replacing nowadays the whatever the VNAs are coming, they are inbuilt of the they will be supporting for a USB power sensor, where you can measure the source power and you can calibrate the source power. So it will be inbuilt of a RF power meter, and intermodulation IMD can be done in the network analyzer, which will be replacing our spectrum analyzers, and harmonics and noise level can be tested using a network analyzer, which will replace a spectrum analyzer. And you can do the noise figure measurement, time domain measurements for some of the fast switching speed data networks, or so for some of the circuits we may be required a time domain measurements, where you can measure the impedance mismatches in the circuit or a system. And for TDR and DDD analyzers, we can do that. Use it to test many types of devices, components, subcomponents, like active and passive components both, which will be including amplifiers, converters, filters, cables, antennas, receivers, etc. So these are some of the devices. And when you come for a VNA terminology, we will talk about the vector and a scalar, passive or active devices, transmission and reflection part, and S parameters. This is a VNA terminology which will be coming whenever you talk about the VNA. These are the terminology, it will be coming into your notice. So vector and scalar. What is this vector and scalar? When you come for the RF signals, I have both the signals, magnitude and phase. So vector will do the measurements of both the magnitude and phase, and scalar is do only the magnitude, which will be used for to do the magnitude by using a detectors, and it was used in 2000 below 2000 years. And now whatever the about 2000, whatever the network analyzers are there, all are vector network analyzers, where they will be measuring both the VA scalar, both the magnitude and the phase of the signals. And when the VNS came, now the scalar network analyzers has discontinued. So passive devices, the devices does not produce any energy, and it will give the only the characteristics. It will give the only the characteristics of the component, and the major component will the major parameter will be the loss. So when you take an example like filters, cables, attenuators, or a field adapters or connectors, so you will be measuring the loss of the device. So this will be the loss will be the major parameter in the passive devices, and we can measure the other parameters like return loss and VSWR also. And when you come for the active devices, the device has a DC voltages. We have to apply a DC voltages to amplify the signal or to activate the device. The major parameter will be the gain, where you will be measuring the gain in the amplifiers and active filters. Some of the frequency converters, we will be measuring the gain, input to output gain kind of thing in the converters. So this is the example of the amplifier, where you will be giving the DC bias from here, and we will be analyzing from input to output what is the gain. Light wave energy to RF energy. So light wave is nothing but, you will take example of a light wave, and you will see how the RF, the other parameters can be characterized. If you take a light wave as an example, if you keep a lens as an example, you will incident a RF signal, and it will be some signal will be reflected back and some will be transmitted to the other port of the device. So when you take the same concentration in the RF device, the same will be applicable in the lens also. So you will be transmitting the signal, incidenting signal, and we will get the reflected by incident, and some signal will be transmitted to the other port of the device, which will be transmitted by incident. The same way we will be using the same terminology, we will be characterizing the RF device. So the R is the incident signal, A is the reflected signal, and B is the transmitted signal. So the ratio measurement is reflected by incident. So that is A by R. So depending on the reflection, these are related to the reflection parameters, which will cover SWR, S parameters S11, S22, reflection coefficient epsilon or R, gamma or R, or impedance, admittance, and return loss. And this is the ratio measurement of a transmission parameters, where it will be measuring the transmitted by incident, which it will give the gain or a loss, or S parameters S21 and S12, transmission coefficient, insertion loss, and group delay. So we will be detailedly talk about the parameters of return loss VSWR in the coming slides. And these are the some of parameters which will be measured using a network analyzers. So transmission and reflection. Transmission is nothing but we will be transmitting from one port to other port. During the ratio measurement of an input, incident, and transmission, we will get the gain or a loss. So reflection is nothing but a major parameter will be return loss, which will be measured the signal reflected to the interface such as a connector, or it is nothing but the incident signal will be reflected back to the same port. So this is called as a reflection parameters. So we will talk about the S parameters. So S parameters are a shortened method for describing a transmission and reflection parameters. And S21, what is this S21? If you come for a S21, the first digit shows the measured port, and second digit it will be showing the originate signal or the sourcing port. So depending on the S21, you can see the port 1 will be the measuring port and port 2 will be the sourcing port. Therefore, S1 is a measurement of a gain or a loss in the forward direction, which will measure the magnitude and phase both. Definitions like S11 is a forward reflection, B1 by A1, and S21 is a forward transmission, B2 by A1, and S12 is a reverse transmission, B1 by A2, and S22 is a B2 by A2. So this is a matrix for the mathematical analysis of S parameters, which will be used for a manipulation and a simulations. So this is the front view of the vector network analyzer. What you will be seeing in the usually the network analyzer, where you will get all the 4 S parameters like S11, S12, S21, and S22 in the display. And when you come for the network analyzer block diagram, so it will be having a functional block diagram, like it will be having a test source. There will be a reflectometer. We will be taking as a bridge or a coupler for this, and there will be a 4 receivers and the 2 ports. And there will be a transfer switch which will be transmitting a transfer from one port to the other port, which will play a main role in the parameters, measurements. So we can measure the forward parameters. What will happen in the forward parameters? Well, like S11, B1 by A1 or S21, B2 by A1. As we know, the simpler A1 measures the incident energy onto the DVT. Whenever we will consider as S11, the switch will shift to the port 1, and the same signal will be, reference signal will be in the A1, and the signal will be transmitted through a coupler, and it will be given to the DUT. And the some signal will be reflected back to the B1, which will measure the reflected energy. So some signal will be transmitted to the B2, which will measure the transmission parameters. So taking this A1 as a reference, we can measure the reflected signal like B1, and transmission parameter can be measured by using the B2 receiver, taking A1 by B2 by A1. Okay, like this we will be measuring the S11 and S22. When you come for a S22 and S12, the switch will be shifted to the port 2. Port 2, from port 2 it will be transmitted to the A2 receiver, and it will pass through the reflectometer and pass to the DUT. So in this case, the A2 will measure the incident energy on the DUT, and the B2 measures the reflected energy, and the B1 measures the transmission energy. So like this, you will be measuring the S22 and S12. And when you come for the VNAs, there will be, most of the time you will be talking about the calibrations. So there is a 2 types of calibration: instrument calibration and measurement calibration. When you come for an instrument calibration, the instrument calibration will be performed in the recommended cal interval at a local service center or an enable accredited calibration center, which ensures that the given specification is meeting with the instrument, which will follow some of the standards like Z50, 540, premium, or an enable accredited certificate kind of thing. So this is the example of the calibration certificate with a standard calibration. And when you come for the measurement calibration, the procedure the VNA goes under through as a part of a setup to measure the device under test. Measurement calibration, usually what does it will be, as we know, the VNA is a RF component, as a RF component which will be having some errors. So which will eliminate that errors by doing the measurement calibration. To establish the 50 ohms reference at the end of the cable, which will do a 0 dB at the end of the cable, and it will extend the reference plane to the end of the cable to do the measurement of the DUT, which will be done using the manual calibration and auto calibration. And methods, we will follow different types of calibration methods are there, which will be related to the device like coaxial or a waveguide or the microstrip or a material measurement kind of thing. So depending on the DUT, we can do the different types of calibration. This is SOLT calibration, which will be used for a coaxial, LRL is used for the coaxial, and there is a SSLT and SSST for the waveguide. And depending on the type of the DUT, we can change the calibration types. This is the mechanical calibration kit with a wooden box, which will be having different standards included in the calibration kit. So this is how it works. The calibration is a fundamental to making the measurements, where you will be defines the reference plane like 0 dB and 0 degrees, and which will remove, using the calibration, we can remove systematic errors due to the frequency response like load match, directivity, and isolation can be done. And random errors can be removed, cannot be removed, because this will be environmental error and cable stability. It depends on the cable stability and the connector repeatability. So these are the random errors cannot be removed thoroughly, but we can remove for a certain extent. And when you come for the calibration types, we are having a full 2-port calibration. We can do a full 2-port calibration, like which will cover all the 4 S parameters. Most of the calibration is done using a full 2-port calibration. And full 1-port calibration, which will cover only for the reflection parameters. When you are measuring the like antennas, you can use a reflection parameters full 1-port calibration, and you can do the calibration and you can measure the device. And there is a 1-part 2-port calibration, which will be used for the simple transmission measurement, where you want to measure the gain or a loss. You can use a 1-part 2-port calibration. And frequency response is nothing equivalent to the transmission measurement, which will be used to measure the loss or a gain, but it will be lower accuracy and it will be the fast in the time. So now we will talk about the antenna measurement using the VNAs. So we are having a 1-port VNA, where, as we know, as we discussed, the antenna will be measuring only the reflection parameters. So for a reflection parameter, the 1-port is sufficient to the network analyzer. So for the 1-port network analyzer, on this having a MS46121B, which goes from 150 kilohertz to 6 gigahertz with a N male connector will be there, which will be connected to the ports directly, port or a device or antenna cable directly, and which will be in the handheld kind of thing, where you can hold in a palm. And what is the requirement for this? It will work from your external PC or a laptop, where it need a Windows 10 or Windows 7 or 8. It will work, and using the USB cable, we want to connect to the PC, and we can use the MS46121B using a Shockline software. So this is another 1-port VNA for MS46131A, which is the same 1-port with the PC controlled and a compact modular USB Shockline series, which works from 1 megahertz to 43.5 gigahertz, which is for a FR2, for a millimeter wave antennas in a 5G, where you can measure the return loss measurements, material measurements, and cable domain, time domain measurements, and distance to fault in a cables. This can be used, which goes from 43 up to 43.5 gigahertz. And we are having a MS46121B. Parallelly, we can connect to different UV antennas. If there is a board with a multiple antennas, you can connect all the antennas. We can connect a 1-port network analyzers, and you can simultaneously analyze up to 16 VNS in a single display, where you can measure all the antennas, return loss and VSWR parameters in a single display. So what is a Smith chart? When you come for antennas or a circuit boards, the Smith chart will be coming to picture. What is this actually? The antenna, the Smith chart is nothing but which will be having a circles in the constant resistance, and it will represent the arcs in a constant reactance. When the point beats or falls in the center of the circle, it is called a 50 ohms. When the point falls in the left side, it is a short, and when the point falls in the right side, it will be open, and the dot will falls in the upper side, it will be the inductive value, and if it falls in the lower side, it will be capacitive value. Depending on the inductive and the capacitive, you can tune the capacitive or inductive to match the impedance to the straight line between or make it center to the 50 ohms. So there is a new MS46121B scalar transmission measurement you can do using a two network analyzers, and you can do a S21 parameter where you will get the magnitude value, where you will be measuring the frequency response and the return loss of the network. Resonance frequency and isolation between the antenna using a log magnitude display, we can do it. The resonance frequency, as we know what is the frequency we have tuned. So you can see in this example, there is a 3 array antennas, 3 array configuration where the resonance frequency is 26.5 gigahertz, 26 gigahertz. You can see it is somewhere here, and slight loss of a bandwidth at a larger arrays. You can see if there is a larger arrays, there is a lot of signal, slight noise in the signal. And when you come for a radiation pattern, so we can do using a 2-port VNS by measuring the radiation of an antenna using 1 as a reference. So this is a reference signal actually, and 1 will be the antenna under test, which will be placed at some distance and which will be made to the rotatable, where it will be keeping 1 as a fixed one and which will be connected to the 1 port of the network analyzer, and 2 will be connected to the other port of the network analyzer. And we will start using a stepper motor. You will start to move this antenna device under test, and you will be parallelly plotting the radiation pattern using the software in the PC. So it will do the radiation pattern measurement, which will be used in the antenna parameters. So when you come for a network analyzer, unresolved network analyzer portfolio, we are having a handheld and a Shockline series mid-range network analyzers and a vector star performance in network analyzers. So in the Shockline, we are having from 50 kilohertz to 43.5 gigahertz, and we are having a E-band network analyzer which is used for automotive radar applications, 55 gigahertz to 92 gigahertz. And we are having a 1 megahertz to 40 gigahertz of a handheld VNS, and the performance in network analyzer starts from 70 kilohertz, goes up to 70 gigahertz. So when you come for high performance in network analyzer and performance and economy, as I told. So Shockline series, we are having a 121B, 131A, and 122B, 322B, and 522B, and 524B, and 522. We are having a 4-port network analyzers also, which is 50 kilohertz to 43.5 gigahertz. In this, they needed an external display to monitor the signal, where the instrument will be controlled from this box. Just we need an external monitor for all this 522B and 534B and 524B and E-band and network analyzer. When you come for the 122B and 322B, we need an external. For a 122B and 121B and 131A, we need an external laptop or a PC where the software runs in the PC or a laptop, and it will be controlled through software, the instruments. The VNS can be controlled. So 122B and 322B are a 2-port network analyzers, which will be similar in the frequency ranges from 1 megahertz to 43.5 gigahertz. Depending on the frequency range, below 18 gigahertz it will be N type, and above 18 gigahertz it will be K type. So you need an external monitor for this one. For a 322B, you need an external monitor. For a 122B, we need to control from a PC or a laptop. For 2-port full reversing VNAs and a K-type converter, it will be having a K-type port connectors where it will be connected to the PC. As I told, it can go up to high power up to plus 5 dBm and low power up to minus 3 dBm. It will cover all the OSLR, SOLR, LRL, LRM calibration, and it is fast. It is a 1U package which will be used for most of the education customers, and they are using for a field application where you can carry with a bag and you can just connect to your laptop and you can use it. And this is used for a manufacturing production area where it will be rack mounted TU size, 2U size, and it will be connected to a AT setup, and they will control through their PC and they will run to the production areas. So 3 frequency models available: 1 megahertz to 8 gigahertz, 20 and 43.5 gigahertz, and without a display. As we know, the major cost of the VNS will be their keyboard and a display. So because there is no without a keyboard and a display, the cost will be less compared to the performance in network analyzers. And we can do some location for identification, fault location identification using a time domain measurements, and it will be small in size. And we are having a 3 years warranty for all the network analyzers, and it is having a USB and a LAN interface for a programming kind of thing like Skippy commands, a LabVIEW, MATLAB programming kind of thing, which is faster than compared to the GPIB models. So this is a 522B and 524B, which starts from 50 kilohertz to 8.5, 20 and 43.5 gigahertz. We are having both the combination for a 2-port, and we are having solution 4-port. And it is having a 2 sources in the 2-port with a 4 receivers, and 4 sources in the 4-port with a 8 receivers, which is integrated with a Windows 7 and PC also. Just we need an external monitor to display in the VNA. And it is having a best industry's best 140 dB dynamic range with a maximum output power of -32 plus 10 dBm, and a fast sweeping speed of 130 microseconds, and the performance with a lower price. It will compare to the benchtop, it will be lesser compared to the other competitor or other network analyzers. And it will be having a 3U package kind of thing where you can mount in the ATE setups, and you can use using a controller. And it is also having a 3 years warranty. So frequency range, as I described, 50 kilohertz to 43.5 gigahertz with a 2-port, and it is used for the passive linear RF and microwave devices for a fast switching speed applications in a signal integrity measurements and over the ear chamber testing we can do. And there is a E-band network analyzer which will be having from 55 gigahertz to 92 gigahertz, which are used mainly for automotive radar segments. And it will be come with the VNA will be included in the inbuilt in this module, which will be directly goes to the devices, which will be easier to connect to devices kind of thing. So it is an economical VNA with a benchtop like performance and frequency ranges. I told it will be EA band, and thermal stability is there, where it will increase the calibration and the measurement inside the instrument, all in size. So this is a Shockline series, all the Shockline series 422B, 46522B, and this is a comparison between all the Shockline series VNS. So when you come for Android, we are having a SI20A which goes up to 40 gigahertz with the highest dynamic range of 110 dB typically, and highest directivity, which works in the NLTL technology, which is called as a non-linear transmission line technology, unrestricted with a 1 hertz of a frequency resolution at 40 gigahertz. So we will be providing a 2 ruggedized connectors also for connecting the ports, and it can measure up to 650 microseconds per point in the measurement speed, and battery life you can use up to 6 hours once it is charged in the field. It is useful for the field applications, and it will measure all the 4 S parameters simultaneously. You can see all the 4 S parameters in the single display. It is user friendly, and we are having some of the B series and C series network analyzers also, which covers from 5 kilohertz to 20 gigahertz with a full two-path and 2-port network analyzer, which will cover all the 4 S parameters in the single display with a directivity of 42 dB. And it can measure all the SOLR. It will support for a coaxial as well as waveguide measurements also with the 350 microseconds per data point. And we are having a combination of a spectrum analyzer in the C series. When you come for a B series, it will be only the VNA. In the C series VNA plus spectrum analyzer, you will get 5 kilohertz to 6 gigahertz, 15 gigahertz, and a 20 gigahertz models. So we can inbuilt of a spectrum analyzer. If you come for a spectrum analyzer features, it can measure occupied bandwidth, channel power, carrier to noise ratio, and it is having dynamic range of 106 dB in 1 giga in 1 hertz RPW, and the noise level or the sensitivity of the instrument is -64 dBm, and it is having a resolution bandwidth of 1 hertz to 10 megahertz. It can do all the traces, trace function and detectors and markers of 6. It can be upgraded for a high accuracy power meter using a USB power sensor, or you can upgrade for a vector voltmeter for the magnitude and phase measurement of a different cables. And you can use you can upgrade for internal bias option also, where you need to measure the where you need to characterize the tower mounted amplifier. Some of the amplifiers where you need an internal bias voltages, you can feed from this and you can analyze the RF character. You can characterize those device. And there is a time domain option where you can measure the impedance mismatch in the circuit or a DUT. So when you come for the 5 reasons why Enritsu VNA is ideal for RF and micro teaching tool is, it is a multiple instruments in a one instrument, and you can use all the vector voltmeter option, network analyzer, bias T, and all in a single instrument, where it will be covering all the spectrum analyzer, network analyzer, and vector voltmeter in a single device, and power meter. So when you come for a vector star, is a high performance vector network analyzer, which is used for a one button option kind of thing. Like when you want to do active measurements of amplifiers and frequency converters and other mixers kind of thing, you can use a performance in network analyzers, which will be having a one button option for the IMD measurements, pulse S parameter measurements, and intermodulation distortion measurements. You can do gain compression measurement can be done in the single display. So we are having from starts from 70 kilohertz to we are having from 20, 40, 70, 110, 125, 145, 120, 220 gigahertz and 1.1 terahertz. Using a VDA and OML modular, we can extend up to 1.1 terahertz, which is having a 2 and 4 ports, and it is having a millimeter wave systems also. So when you come for a frequency selection, we can do using the frequencies. We are having up to 145, the vector star, and 55 to 92, the Shockline series, and 43.5 gigahertz, we are having 100 as well as a Shockline series VNAs. When you come for a port count, we are in the one port, we are having a Shockline series 121B and 131A. And the two port, we are having a 122B, 322B, and 522B. And 2 port and 4 port, we are having a Shockline series 522B series and 464XB series, which is a vector star. So this is about the network analyzer selection guide, and this is the end of the my PPT. Please let me know if you have any questions kind of thing. Hello? Hello?
Yeah.
Any questions, sir?
Please go on. Please go on. Some Hasnavi Shahid.
Any questions? Let me check. Why modern VNA are not designed without an instrument calibration? Why modern?
Yeah, there are no more questions. Then
It take a transit time, and at times VNA got damage on the.
thank you, Lakshmi Narayan.
Thank you, sir.
We are running short of time, so I'm just hurrying. So thank you, Lakshmi Narayan, for that wonderful lecture. You introduced your product. That's good. May I now invite Professor Anil Kumar, sir, to start the proceedings for the valedictory ceremony. Thank you.
Thank you, sir. Thank you for your.
Thank you. Thank you very much, Lakshmi.
Thank you, sir.
Good afternoon, everybody. After a 5-day long tight schedule of 14 sessions, we are arriving to the final item in the agenda, the valedictory session. I hope all of you have enjoyed the discussions throughout. Now, it is a time to hear from your side. We are very, very much interested to receive your feedback. Some of you, please come forward and give your feedback and suggestions for improving our future programs. Any of you, please come forward. You can unmute your mic and speak out. May I invite Dr. Anupam Tiwari for a few speaking few words. Dr. Anupam Tiwari.
Sir, he written a message in the chat box that he's unable to speak now. He
Okay.
has logged in through his computer.
Okay. Now, may I invite Nidhi Sharma for giving your feedback?
Good morning to all. The FDP is very well organized. All the sessions are very well organized, and I collect valuable knowledge from this FDP. This is very well organized, and very well time management is also very good, and resource persons are also good. Plus controlling section of this FDP is very good. Thank you. I'm delighted to be part of this FDP.
Okay, thank you. Now, may I invite some faculty members from within Kerala? Anybody? Nias, may I invite Nias for speaking few words?
Thank you for the invitation, sir. All the sessions were very informative, starting from the Lilikuti ma'am session and Samir sir sessions. All the sessions were very well organized and very informative. Such a person like me, who is looking forward for the research in wireless communication area, it was very much helpful for me to find out an area or to know more about the different areas which I could explore. From my behalf, I would like to thank all the FDP coordinators, Sivi sir, Omar sir, etc., for arranging this wonderful FDP, and all the research persons were very good. Thank you, sir.
Any other persons? Any other participants? If you're interested to give a feedback, please come forward. If no other persons are,
Good afternoon, sir. Good evening, everyone. So regarding the FDP, this was a very informative and very structured FDP. Thank you all the coordinators behind this FDP. I want to thank each and everyone behind this. Everyone after the sessions, the coordinator shared the resources, so this was very informative. Thank you, sir. Thank you so much.
any other participant? If you are interested to give the feedback, please.
Good evening, all. Good evening, sir.
Again.
It's my pleasure to be part of this FDP. In fact, I am an alumni also of Department of PC, College of Engineering, Karunagapalli, from the very first batch, 2004 pass out. And this, as usual, this FDP was very well coordinated, sir. I have been to many FDPs conducted by College of Engineering, Karunagapalli, and we learned various new technological tools and methods also from the area of communication. Advanced communication also, and it has been a definitely add-on to our teaching arsenal also. My heartfelt gratitude to all the members of the organizing committee, especially to the principals, Anil Kumar sir, and also to Millie ma'am also for giving us this wonderful opportunity. Thank you all. Thank you, sir.
Thank you, Asina.
Sir, good morning. I am Anupam Tiwari. Sorry, good afternoon.
Yes, please.
Sir, I am a fellow member of IET, and it was a very nice learning experience with your FTP. and everything was what you say organized well, and all the resource teachers and professors are excellent. Thank you, sir.
Thank you, sir. Any other participants?
Thank you very much, sir. I am Trishan Batro. All the sessions are very excellent sessions. All the resources and resources are very excellent. These are very informative sessions. All the sessions are, and this will be very important to increase our knowledge about the 5G console system, wireless console system.
Okay. If no other participants are interested to give the
I think
feedback.
someone else is trying to speak.
Yeah, please, definitely.
Hello, sir.
Thank you, Trilogy.
Yeah. Yes, hearing.
All the systems are very excellent, Susan. I am very thankful to all the resources professors, and this also helps to increase our knowledge for 5G conversations, wireless conversation, optical conversation, etc. All the sessions are very excellent sessions. Thank you so much, sir.
Okay, the participants, you may please point out the drawbacks also, so that we can improve in the future programs.
So far, sir, I cannot see any drawback. If any drawbacks, then I will see later in the next session also. Coming session, if it's possible for the conduct another sessions.
Okay, thank you.
Thank you, sir.
Anybody else? Okay, if no other participants are interested to share your feedback here, let me proceed to the next. Our head of the department, ECE, Dr. Govamar, is available here. I invite Dr. Govamar for sharing few words with our participants and coordinators.
Okay, good afternoon to all of you. Am I audible to you, sir?
Yeah, please.
Okay. The Faculty Development Program on Advanced Communication Systems Research Perspective, organized by the Department of Electronics and Communication Engineering, College of Engineering, Karunagapalli, is concluded today. The program was started by the talk on fundamental stochastic process by Professor Tillikutti from NIT Calicut. It gone through different aspects of the advanced communication aspect, like the use of machine learning in communication systems, different kinds of high frequency design aspects with HFSS, the next generation internet, etc. So I am happy to know that there was a good participation from all over India for this program. From your valuable feedback that I understood, what I understood is that the participants must have gained a good exposure to the advanced aspects of electronic communication techniques, which will be useful for you in your future teaching and research activities. If it was not for this COVID pandemic condition, we would have happily welcomed all of you to our institution. Still, I feel that within the limited environments of the online platform, we could manage conveying ideas with the proper interactions. I wholeheartedly appreciate all the participants for the active involvement in this program. A special thanks to Dr. Anil Kumar Sevi and Professor Shanu and all the organizing committee members for the wonderful coordination of this program and making it a success. Thank you.
Now, let me come to the end of this session. Now, at the end of this session, as a coordinator, it is my duty to propose a vote of thanks. So we have 148 registered participants, but on an average, around 100 participants were attending the sessions. Active participants are the heart of all such training programs. All of the resource persons were happy as the sessions are highly interactive. So on behalf of the coordinators, Department of Electronics and Communication Engineering, and for all the resource persons, I express our sincere thanks to all the participants for your active participation throughout these 14 sessions. Now, the second component, equally responsible for the success of such a program, is the resource persons. We had a set of wonderful resource persons with real research experience in the respective topics. All of them were very particular in keeping the schedule in time. So on behalf of each of you, coordinators and the department, I thank each of the experts cooperated with us in this FDP. Next, I thank the AICT for supporting us in organizing this FDP. Actually, we can see this pandemic situation with a positive outcome like this on online programs. So before that, we were never think of such an online program. So due to this online organization of various programs, all the participants, irrespective of their location, can participate in different programs organized at different corners of the country. That's a very positive outcome, I think. So I would like to take this opportunity to express our gratitude to the faculty members and HOD, Department of ECE, for supporting us in organizing this FDP and permitting us to use the resources available in the department as well as the institute. Finally, my co-coordinators, as I told in the inaugural function, they were instrumental with me from the preparation of the proposal. In these 5 days, I could not attend the sessions throughout due to some other assignments I had. In my absence, my colleagues, Professor Shanu, Professor Mili, and Venu were managing all the issues successfully. So I express my heartfelt gratitude to each of you, Shanu, Mili, and Venu. Once again, I thank each one of you. Wish you all a very best in the future activities. Be in touch with us. We will definitely invite all of you to all our future similar events. Please cooperate with us in all these programs. Also, you may please invite us to participate in your programs also. Thank you. Now, it is a time for the evaluation. So the questions will be shared. You can take half an hour for completing that, filling that multiple choice questions. Then after this evaluation, our 5-day FDP will formally conclude. And after this, you please remember to submit your feedback to the Adal Academy portal. It is a mandatory requirement for issuing your certificates. So please proceed to the next evaluation. Thank you.
Link for evaluation is there in your chat, and I have shared it in WhatsApp group also. You can take 30 minutes to complete. Okay, thank you. Thank you, participants, for your cooperation. Thank you.
I think the participants can leave the session. You can you can submit that Google form, the questionnaire.
Sir?
Yes.
This session feedback not posted in the